Welcome back. We're looking at graphing rational functions. And that will lead back to our domains of rational functions, and we'll see how that fits in as we start graphing. I'm going to start with a relatively easy one. Y equals 1 divided by x. Do you notice that in the domain x cannot be 0 because that would make 0 in our denominator? So we know we've got to skip it. Let's get our graph ready and see what we're going to do. Our x-axis, our y-axis, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, let's think up some values of x that we might want to use. We're just skipping 0 for x. So we might want to do -3, -2, -1, skip 0, go to 1, to 2, to 3 for our x, and find our y to go with it. Well, 1 divided by -3 is -1/3. Then 1 divided by -2 is -1/2. 1 divided by -1 is -1. 1 divided by 1 is 1. Then we have a half. Then we have 1/3. So graphing 1, 1, 1, 1/2, and 3, 1/3, we have those. Graphing -1, -1/3, -2, -1, -1, pardon me, I'm not looking right. Let's erase that mark. Get our graph back in shape here. So let's graph -1, -1 here, -2, -1/2, -3, -1/3. I've got some questions here. What happens as x approaches 0? We know we have to skip it, but you know, there are numbers like 1/10, 100th, 1,000th, all those numbers we can use. So what's happening then? Notice the new symbol, x is approaching 0. Let's put a plus here, and that means x is approaching 0 from the right. Well, what numbers would we look? Between 1 and 0, we might use 1/10, 1/100th, 1/1000th, so 1/10, 1/100th, 1,000th. Now, 1 divided by 1/10 is actually the reciprocal of 1/10, which is 10. 1 divided by 1/100th would give us 100. 1 divided by 1,000th will give us 1,000. Let's see, 1/10, 10. So if I have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going to be pretty close here. And let's think about that. Woo, 1/100th, we're up to 100. Man, that graph is just going straight on up, but it doesn't hit 0. So let's see what it's looking like here so far. There we are with our graph. Looks to me like as x approaches 0 from the right, y is approaching positive infinity. And that's exactly what's happening. Well, let's see what happens as x approaches 0 from the left. This time, for our x's, we might use -1/10, -100th, and -1,000th. So with reciprocals, we get -10, -100, and -1,000. So -1/10, -10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's way on down here. And then get a little closer to 0, and we're even further down. Man, we're headed, aren't we? Some more closer and closer to our axis. So we've got that much graph. We know we don't cross it because we know we can't use 0. We thought about that to begin with. So it looks like we're just getting closer and closer and closer to 0, and y is just totally going nuts, either toward negative infinity or positive infinity. And that is actually the definition of a vertical asymptote. We have a vertical asymptote where x equals 0 because as x gets really, really close to 0, the number we can't use, y approaches either positive or negative infinity, or we say it increases or decreases without bound. So, vertical asymptote is x equals 0. So we've got probably the center part of our graph done. The next question we want to know is what happens here as x goes way, way on itself. What's going to happen? So let's erase this list of values, both old lists, and start a new one. So we have our x's and y's again. And let's get some big numbers for x. Let's go on. We were at 3, weren't we? Why don't we do about a 5, maybe a 10? Think about what happens when we go to 100 and 1,000. We get 1/5, 1/10, 1/100th, 1/1000th. Can you see that the larger we get for x, the smaller amount we have? Let's think about 10. If I have 10 people and I have 1 cake, I get 1/10 of the cake. Probably not too bad. If it's a really big cake, it'll be okay to get 1/100th of it. 1/1000th of it, I'm not getting much. What about 1,000,000? If I get 1/1,000,000th of a piece of cake, I just as well have no cake so far as I'm concerned. That would be such a tiny crumb, it wouldn't be worth thinking about. So what's happening? As x approaches positive infinity, y is headed toward 0. So I can just draw it there. Now 1 over a positive number is always positive, so I will never hit 0 for y because 1 divided by positive is positive. I will get so close that I might feel like I have no cake or that I'm at 0, but reality is I really do have maybe a fraction of a crumb. And you can see if we go the other direction with the negative numbers and let y approach negative infinity, or x approach negative infinity, that we're approaching 0 again for y. But this time from below the y-axis, because if I'm plugging in negative numbers for x, I always get a negative number. Now that means that y equals 0 is a horizontal asymptote. By definition, as x approaches plus or minus infinity, if y approaches a constant, which in our case was 0, then we have a horizontal asymptote where y equals that constant that it approaches but never actually reaches. Okay, does that make sense to you? Let's look at another one. What happens when we have a function that we start out with and we can reduce? We talked about that briefly a few minutes ago, that when we reduce, we look at the old domain. So if I have y equals 1 divided, let's do x squared divided by x, then our domain is exactly what it was a few minutes ago. X can't be 0. But now what happens is I can reduce, and y equals x so long as we don't use 0 for x. What is y equals x? I believe that's a line, isn't it? So I'm just going to graph a line real quickly. Y equals x, it would be 0, 0, 1, 1, 2, 2, 3, 3, so forth. For y equals x, draw my line here. And then I notice I can't use 0, so I draw myself an open circle on 0, and that's my graph right there. I cannot use 0, but it's the graph of a line with an empty hole. So did you notice what was happening? Let's go back to the previous slide. We skipped x equals 0 here, and we had an asymptote where x equals 0. In the next one we skipped 0, but we had an empty hole because our little problem just reduced away and we just had to remember what was in the domain. So those are the two things that happen. When we see what we can't use for the domain, we'll either have an empty circle or we'll have an asymptote at that particular place on the graph. So let's look at some we might want to graph here. Or, I'll tell you what, let's practice something. Let's say that we have another hand-drawn graph, and we're going to answer some questions about it. This is 1, 2, 1, 2, and I'm going to have a vertical asymptote. I'm going to just abbreviate it. Vertical asymptote at x equals 2, and guess what? I'm going to have 2 asymptotes. I'm going to have an asymptote that's vertical at x equals -2. And then I'm going to have, let's change color so we can see it better, a horizontal asymptote, HA for horizontal asymptote, of y equals 0 on my graph. This will be an interesting little fellow, won't it? This graph looks like this. It does a little wiggle, kind of like y equals x cubed does a little wiggle. And it looks like this here. And it looks like this right here. Now, what happens as x approaches 2 from the right? What is f of x doing? It's headed toward what? Well, we find 2 here. We go to the right. We start heading toward it. As x gets closer and closer to 2, y is getting closer and closer to what? Positive infinity. Okay. What happens as x approaches positive infinity? What happens to f of x? Well, let's see. It goes on and on and on. I know I'm headed toward an asymptote of y equals 0. So f of x approaches 0. Does that make sense to you? That's what's happening when we have asymptotes. As we get really, really, really close to that number from the right, we can see y is just going up crazily toward positive infinity. As we approach 2 from the left, it's going toward negative infinity. So if I know there's an asymptote, I know it's never hitting that spot, but getting very close to it when it's a vertical asymptote. Notice something else interesting here. The graph is crossing the horizontal asymptote, and that is possible to cross a horizontal asymptote because we never say that y can't be 0 in this problem, but we say that x can't be a number, and when x can't be a number, we can't cross it at all. So that's an interesting thought as we get ready to graph some more functions.